Now, a multi-step conversion. So we barely got through these conversions, but through those one-step ones, but the multi-step ones are necessary. And this is actually what we're going to be spending most of our time on is chemistry. In chemistry, that is these multi-step conversions. And so when do you need them? Well, when neither unit in the question is a base unit, so you don't have a simple prefix conversion, or you don't have a direct conversion. You're going to have to set up kind of like a tree of conversions to get you there. So how you can dissect or how you can determine whether you need to do a multi-step conversion or not is if you read the problem and you're given no base unit, but you're given 2 prefixes instead, you're going to need multiple steps. And I'll show you one as an example. How many millimeters are in 10 centimeters? So millimeter, centimeter, there's 2 prefixes there. Here's one, here's the other. So the base unit is meters. Because you have 2 prefixes, you know that you're going to need multiple steps, because even though, you know, looking at the prefixes above in your notes on that first slide that we had, there's no straight conversion from millimeters to centimeters, or you may not know that one exists. So you're going to have to do multiple steps. So how do you do this, these multiple steps? First, you convert to the common unit. You convert to the base unit, because you could do centimeters to meters, and you could do meters to millimeters. So the meter itself, the base unit, is the common link. So first convert to the base unit, then from the base unit get to the desired unit, or that, you know, the one that you're asked for in the problem. Now the nice thing about these conversion fractions, the T-charts that we set up, is that you can do it all as one big step. It's going to look almost like a railroad track. And I'll show you what on the next slide here, an example. So here's the problem. How many millimeters are in 10 centimeters? The one from the previous slide. Base unit is meters. So that's what we're going to convert to first. Start with the number in the problem. Set up your first conversion fraction. So this is just converting to meters. One-step conversion, not too big of a deal. Centimeters cancel. So centimeters are gone in a way. Now this is basically just converting from meters to millimeters now. It's a one-step problem now. We just have to do one more. So we have one additional conversion fraction. Notice that you have meters here and meters here, so now those cancel. These numbers here make it true that there's 10 to the third millimeters in 1 meter. So if you look at all the red, everything that's canceled, anything that's left, you've got a number, number, a number, this unit, and this number. These 2 units are gone. So let's deal with the numbers first. 10 times 10 to the third divided by 10 to the second. So that's 10 is like 10 to the 1 times 10 to the third. You add those together, so that'd be 10 to the fourth divided by 10 to the second. You can subtract the exponents and get 10 to the second millimeters. Notice the jumping off unit here, it's this last one, that becomes our unit in the answer. So 2-step conversions, again, are when you're going from 2 units that maybe don't have a common link between them, or they can't go straight to one or the other. So here's another example, kind of similar in a way, you'll notice. I'd say pause the video, see if you can do this. This is going to be the last practice problem, so you want to make sure to get it done and see if you can handle it, and we'll be doing more in class. But take a look, see if you can do it, pause the video. So here we go. Start with the number in the problem, 2.5 centiseconds. Convert to seconds using this. Then convert from seconds to milliseconds. Dealing with the math, the numbers, because all the units are gone here except for the one we want, because it says how many milliseconds. That's what we're trying to get to. So you got 2.5 times 10 to the third on top, 2.5 times 10 to the third, and then what is in the bottom is 10 to the second. So it's 2.5, and then 10 to the third divided by 10 to the second is just 10 to the 1. So 2.5 times 10 is going to be 25 milliseconds. What you might notice is that conversion, this practice problem right here, looks exactly the same as the one we did before. And that's because the prefixes are the same. So you're going from a centi prefix to a milli prefix. So these two-step conversions, they can, once you learn the system and once you learn the prefixes, a lot of these conversions are going to look very similar. And I know that this is going to be one of the more challenging lessons, but with some practice, we'll get it done. To recap, we looked at base units and the metric prefixes, at least some of the common ones. There's a bunch more. We then learned the concept of dimensional analysis as a skill, where you have conversion fractions, and then you're multiplying by 1 times 1 times 1. And then finally, unit conversion calculations. So that's going from one unit to another, using dimensional analysis properly, and being able to change languages, change the language of units. And so that's going to be it for unit conversions. We're certainly going to do some practice in class to get there, and then we'll build on this in later lessons.